Section 1.5 is investments involving regular payments. So regular payments just means that you are either putting money in, whether you're paying off a loan at a regular amount of time, or you're making an investment and you invest a certain amount of money however many times a year, or just once a year. It doesn't really matter. So as it says there in bold at the top, these types of problems can only be solved using the TVM solver or a spreadsheet, or by doing a lot of repetitive calculations by hand. So that's where knowing how to use your graphing calculator for this is going to be extremely helpful. Not even going to try this name, but he's 18 years old and he needs money for post-secondary education. On his 14th birthday, his family deposited $1,000 into an RESP at 3% compounded annually. Since then, he has deposited $1,000 of his own money, earned by working part-time, into the account each year. So how much money is in his account, and how much interest has it earned altogether? So if you think about this when we're looking at it, the number of years that he has, so from 14 to 18 he has 4 years. We know that his interest that he is earning every time is 3%. Present value, well, he puts in that $1,000. Our payment, now this one we know, or we need to change that value because he is putting in a regular payment, in this case every year. So he puts in every year $1,000. So the PV is the initial investment that they put in, and the PMT is the amount that they put in every time. Future value is what we're trying to figure out. He does these payments once a year, and it's compounded annually. So if we bring up the calculator here. So our N was equal to 4. Interest was 3. Present value, so he or his family put in $1,000. Every year he's taking $1,000 and putting it in there. We want to find the future value. Payment per year and compounded per year are the same. So on future value here, if you hit alpha and enter, shows you that his future value, or the A, is equal to $5,309.14. So this asks then how much interest has he earned altogether. So our interest is going to be his future value minus all deposited money. So if we look at all of his deposited money, this started at age 14, right? So he had $1,000 put in by his family at age 14. From the time he was 14 to 15, he put in 1,000. 15 to 16, he put in 1,000. 16 to 17, he put in 1,000, and then 17 to 18, he put in 1,000. So he's put in $1,000 every year, plus that initial $1,000 that his family invested for him. So this is going to be 5,000 minus your 5,309.14. So that means he earned $309.14 in interest. So Darva is saving for a trip to Australia in 5 years. She plans to work on a student visa while she's there, so she needs enough money for a return flight and her expenses until she finds a job. She deposits $500 in her savings account, so that is her payment. She's got nothing in there to start with, right? At the end of each 6-month period. The account earns 3.8% compounded semi-annually. How much money will be in the account after 5 years, and how much money will she have earned in interest? So her present value, she's starting at nothing. but every payment period she's putting in $500. Her interest rate was 3.8%. The N for this one, um, you need to, when you're doing these, you need to, because they are doing this as a payment per period, and it's a compound interest one, so you need to take your N and make it that 5 years times how many times it's done, so the number of periods altogether in this case would be 10. Future value is what we're trying to figure out. Payments per year, it says she's doing this every 6 months, so twice a year, and this is compounded, where is that? Semi-annually, so twice. So we have N is equal to 10, interest is 3.8. Present value, she didn't have anything when she started, but she is investing $500 every 6 months. Future value, well, you can actually just leave it there and come back to it. Payment per year is 2. Compounds per year is 2. So we go back to future value, alpha, enter, and you find out that your future value, or your A, is equal to $5,449.90. So it says how much money will be in the account at the end of 5 years. So she'll have $5,449.90. If we want to figure out how much she deposited, so she deposited, I can't write. She deposited herself $500, and she did it twice a year for 5 years, so that's 10,000. So she, or 10, so she deposited $5,000 of her own money. So how much of this money will be interest earned? So interest is equal to your A minus P. So that's going to be $5,449.90 minus the $5,000 of her own money she deposited. So $449.90 is interest. Adam makes a $200 payment at the end of each year into an investment that earns 5% compounded annually. Blake, excuse me, made a single investment at 5% compounded annually. At the end of 5 years, their future values were equal. So A, what was their future values? So if we look at this, where are we? For Adam, number of years that he did this was 5 years. Interest rate was 5%. Present value, we're not sure. Payments, sorry, 0, because he's starting at nothing. Future value is what we're trying to figure out. He's doing this yearly, and the interest is compounded yearly. So if you put that into your calculator, whoops. So we have 5, 5. Present value is 0 because they're starting at nothing, but they're putting in 200. Come back to that. This is done yearly and yearly. So go back to future value, alpha, enter. So Adams, so this is for A. And Blake's, because it says here they their future values were equal. So $1,105.13. So, B part says, what principal amount did Blake invest 5 years ago? So if we're using the calculator here, we have n is equal to, whoops, not 1, just going to put 15. N was equal to 5. Your interest was equal to 5. Your present value, that's what we're trying to find. Because we're trying to find present value, we're not trying to calculate payments in here, so we just leave that at 0. Future value is at $1,105.13. Payments per year is 1, and compounds per year is 1. So if we try this, we have 5, 5. This payments per year needs to be 0. Future value we can leave. So if we go to present value, move up, there we go. Alpha, enter. $865.90. So the present value or the principal invested was $865.90. So C says, who earned more interest and why? So if we take a look at Adam, his own investment, so he had 5 years and he invested $200 a year. So he invested $1,000 of his own. So that means his future value minus the principal will be $1,105.13 minus $1,000. So he earned only $105.13 interest. Whereas Blake, his future value minus what he invested was $1,005.13, and he only invested $865.90 over the course of the 5 years. So he had $232.93. So Blake then earned more interest. And that's because he deposited a larger principal instead of the yearly deposits. So if you think about this, you're going to make more money if you deposit $1,000 to start with, because that $1,000, your interest, let's say it's a 5% interest, so you're going to earn $50 the first year, so $1,050, then you're going to earn interest on that $1,050, and then it'll keep adding on for those 5 years. Whereas the other way, if you took $1,000 but only put $200 in per year, your first year you're only earning interest on $200, your second year you're only earning interest on $210, and so on and so on and so on. So if you do a larger lump sum, there's more money to earn interest on that's going to be compounded yearly, or whatever the compound time is. So Jeremiah deposits $750 into an investment account at the end of every 3 months. Interest is compounded quarterly. The term is 3 years, and the future value is $10,059.97. What annual rate of interest does Jeremiah's interest earn? If you tried to do this by hand, you wouldn't be able to do it because you're trying to find your I, and it's going to take some amazing calculations to get there. So that's where using this calculator is going to be that much better. So compounded quarterly means that this is happening 4 times. So for this one, our payments per, or our number of payment periods is that 3 years times quarterly, so that's 12. Our interest is what we're trying to find. Present value, we don't know. He's starting at 0 from as far as we know. And he's putting in $750 every 3 months. He ends up with $10,059.07 at the end of those 3 years. So his payments per year, he's putting this $750 in 4 times a year, and his interest is compounded quarterly. So it's four times a year. So we put this in our calculator. N is equal to 12. Don't know the interest rate, so we can just skip over it. Present value, he started at 0. His payments, he's putting in $750, so remember it has to be a negative. Future value was $10,059. Oops. And 7 cents. He's doing this 4 times a year and compounded 4 times a year. So go back up to interest, alpha, enter, 8.0000, so interest is equal to 8%. So if we want to find that, this one was finding the interest rate. What if we want to find the regular payments? How much did they put in every payment period? So Celia wants to have $300,000 in 20 years. So that's $300,000 for future value. She's doing this for 20 years. It's compounded annually, so that means there's only 20% or 20 payment periods. She's earning this at 10.8%. Her present value, we don't know. She's at 0. This is compounded annually, so payments per year, she's investing once a year, and she is compounding the interest once a year. So put that information in here. She's at 20. Interest is 10.8. Starting at 0. Her payments, we don't know. She wants to have $300,000. And this is once a year she's investing, and once a year the interest is being compounded. So go back to payments. Alpha, enter. So her payments are $4,781.09 a year. So the question is, how much interest is she going to earn over the course of the 20 years? So we know interest is equal to your future value minus your principal. So her future value was $300,000 minus her principal. So the amount she invested was $4,781.09, and she did that 20 times. So we multiply it by 20. So she invested $204,378.20. So she's earned over the course of 20 years about 300 to 200 for about $96,000 interest. That's a very good rate of return. So on Lewis's 20th birthday, he started to make regular payments of $1,000. So his payments, $1,000 minus $1,000 to an investment account at the end of every 6 months. So that means he's doing it twice per year. He wants to save for a down payment on his home. His investment earns 3.5% interest, compounded semi-annually, so it's twice. At what age will he have more than $18,000? So we want a future value of 18,000. Present value is 0. We want to know how long this is going to take him. Calculator. So we don't know n. Put it as 0 if it helps you remember to come back there. It's 3.5% interest. He's starting at 0. He's putting in $1,000 twice a year. He wants to have $18,000. He's paying it twice a year, and it's compounded twice a year. Go up to n, if I can get there. Alpha, enter. So 15.78. But remember, this is being that n, that's being done twice per year. So you have to divide by 2 to get 7.89 years, or basically 8 years. So it's going to take him 8 years to get there. At what age will he have more than $18,000? So by age 28, he will have more than $28,000. So the thing to remember here, n is the number of compounding periods. So to get the number of years, you have to divide by the compounding periods. Per year. So just a summary, so present value formula is that a over 1 plus I to the power of n. Some questions you're going to be able to do it, some questions it's just not going to be possible. It's going to take far too much calculations to do over and over and over again when you're doing like the compound interest type. So it's better just to put it into your calculator. When you're trying to find your future value to present value ratio, the bigger the ratio, the better it is for you. So that was a little bit, we did a little bit of that in section 1.4. You'll come across it again here. So when your future value to present value ratio is bigger, so like that one question we had, it was 2.41 or something, and then the other way was 2.03. The bigger the ratio, the better your return is.